Thank you very much. Well, I'm really excited to be here in Hamburg. It's the second time that I'm in the DevFest. So let's get started. Okay, so before I start, I want to introduce myself. So yeah, that's my Twitter handle. I come from Colombia. I'm living in Berlin right now. I've been here in Germany for 1.5 years. As Natalia said, I work for Zalando, which is the European largest fashion e-commerce. Really interesting company, many interesting projects. I'm also part of the this Google program called Google Developer Expert. My specialty is Google Cloud Platform. So yeah, that's me. Okay, the agenda for today. First, I want to introduce this concept called API first, and we'll see what it encompasses and how can we implement it. And then we will see some of the tools. First, OpenAPI and Connexion, and then the Google Cloud part of the talk, which is made of App Engine and Google Cloud Endpoints. Okay, so as we all know, APIs are important, are very important, especially nowadays that we no longer depend only on our code, but we also start depending on third parties. Many companies are breaking their monoliths into microservices, and now teams depend on other teams, and it's no longer like a big backend application only. Front ends and backends are being separated. So at every layer, we are going to be dealing with APIs. And just in the context of the talk, APIs, I will refer to HTTP-based APIs, usually following RESTful patterns. So yeah, even though we know APIs are important, sometimes as developers, we tend to focus a lot of our attention and time in the implementation. And we forget about the other parts, the other teams that depend on our API. So many companies started well seeing challenges in how teams were building APIs, and they started to come out with different set of practices and also different ideas in how to make API-based services work better. So as you might imagine, API first starts with specifying the API first and then doing the code. That's kind of intuitive, but it goes beyond that. It's more about ensuring the high quality of the API. So treating your API as a first-class citizen, not only at the beginning when you design it, but also after you implement it in every update to your app, also in maintenance when you are fixing bugs. You always have to be careful and think in the API. Also, you should do a little put effort into making sure your API is easy to, not only easy to use, which is kind of ideal if your users also learn in an easy way and can understand what your API is about. And trying to be general, so you might have different kinds of clients, for example, mobile applications, for example, other servers, or even like a web UI, but the API shouldn't be coupled with any of them. The API shouldn't contain any implementation details like the database schema or the platform, the framework, the programming language. Another characteristic of a good API is that it takes into account the different teams and the different stakeholders that will use it. So most of the time, you are not going to be the only one developing the API, and you are not going to be the only one consuming the API. So many of the activities are related to collaboration. For example, having peer reviews, generating discussion around the API, and having feedback. That's especially useful in the first phases. And also following best practices, which well, you can find in other providers or in other projects, and keeping your APIs consistent, because if you're working with other teams, you don't want people to learn different styles and different syntaxes, for example, even if it's a public API or if it's an internal API. And of course, the API should be the source of the documentation. So you want to be explicit and avoid surprises when people use your API. And the third characteristic that I want to mention is API should be long-lasting. That means that they should stand the test of time. So think long-term when you are doing your API, because other people will rely on it, and they will build software on top of it. And the last thing you want to do is get these people angry because you make a change. So one example of this is, for example, imagine you have a field which is required. It's okay if later you decide that field is no longer required and it's optional, but if you do the opposite change, it might cause some problems, because people are not validating, and then if you introduce this constraint, maybe you break some other people's code. So it's important to have this in mind. All right, so those were the concepts around API first. And there were many attempts of building like a standard way to have all these, or to enforce all these considerations into a specific format. But in the latest years, one caught a lot of attention and a lot of momentum, and it was called Swagger, and now is part of the OpenAPI initiative. So what is it? It's a standard for specifying RESTful APIs, and the goal is to help both developers and also other programs to discover your API and understand what are the services that it provides. It's programming language agnostic. It's made of one file, which could be either JSON or YAML. And it's not only that, but also a huge ecosystems of different kinds of tools, like some of the ones that we were going to discuss today. Okay, so this is an example of a file, of an OpenAPI file. So the first things that you will see is that it specifies the different paths and also the HTTP methods that your API will support. So for example, here is the typical pet store example. So here it will be get a pet by its ID, and the ID will be part of the path. It also has some fields that are purely for documentation, and here we can see the tags, which will group the different API operation, and the summary, which is meant for humans to understand what the operation is about. It also describes the different status code. So when a user calls the API, they know like which are the different possibilities. If everything goes right, then you get a 200, for example, or you can get a 404 error. and of course, the structure of the response. So in this case, our response will contain an object, which we will call a pet, which is like part of our model. And we also have a space to like define some validation. Is usually like what is required. Maybe if there is like a specific format, it should follow. Okay, so you might be asking, okay, so is that file enough? It's kind of simple. And yeah, that's a good start, having the specification in OpenAPI format might solve many problems. But if you do the implementation manually, you can start seeing more problems down the road. So the first one is that if you keep the code and the spec separated, then you might introduce new fields in the spec, and the code doesn't reflect that, so you'll have errors there. And yeah, we don't want that. Well, many people started having these issues, and they decided to, for example, make a framework that generates the API spec automatically. So they put some kind of annotations in the code, and then they run a tool, and they get the file automatically. And that's improvement, but it turns out the implementation tends to change more rapidly than the API should. So you can start having problems where you do, for example, a refactoring and change the names of the methods, and then your API also falls into the refactoring, and then you break all the clients. And another problem that some people start having is that you start leaking some implementation details into the API with this approach. Okay, so what's the other option? We can, of course, generate code from the spec. So even Swagger has a tool for where you give the file, and it will generate like the skeleton of your backend. So this is great. It works great in the first time, but the problem is when you start doing updates and you want to, well, you don't want to overwrite your existing code. So some colleagues of mine at Zalando, they saw this problem and they came up with this solution. So what is Connexion? Connexion is a framework. It's for Python, and it's built on top of another framework called Flask. It's a very lightweight framework just for API development. And it solves some of the issues, and it doesn't generate either the specification or the code. It keeps both separate. So what does it do? Basically, it's 4 things. The first one, request and response validation. So make sure that you are getting all the required fields in the request, and that you are also including the right fields in the response. So that's great, and you don't have to like manually be worried about like new fields in the spec, because the framework will take care of that. It also does automatic routing. That means that you declare which Python function will handle the request, and Connexion will route the request to the appropriate handler. It also performs typecasting for example, for parameters. That's useful if you are expecting, for example, booleans or integers, and you don't want to do the transformation inside of your code. Connexion will do that automatically. And it also has some OAuth support for authentication, but we will talk about that later. So it's very simple. You provide a In the configuration, you provide a URL to validate or to get the information given a token. And if you include the token in the request, Connexion will resolve, like, will check the information for that token and will inject that into your Python handler. So let's see in how it works in action. So here we have our OpenAPI spec in the right and our Python file in the left. So the first thing is the automatic routing. As you can see there, we have a new field called operation ID. And here we say, okay, for this operation, for this API call, call the appropriate Python function, in this case, app.getPet. It also has a typecasting. For example, here we have our ID, which is an integer, for example, and in our Python function, we just assume it comes as an integer. We don't have to do the casting manually. And it also does the serialization. So as you can see, we retrieve the pet, in this case from a dictionary, and that's a Python dictionary, and we just return it, and Connexion will take care of the serialization to a JSON string. Or if it's not found, then it has like these convenience methods for returning, like for example, 404. Okay, so let's see quickly at the implementation. So this implementation is like the most simple one because we're not going to be using like a database. We're just going to use a memory to store our pets. So let me see if I can zoom. So one of the things that I like about Connexion is that it doesn't like pollute your code with different codes to the framework. If you see the different functions are like pure Python functions, and yeah, probably for example, this like when there is no content, you have these convenience responses from the framework, and skip the authentication, and then we have here our initialization. We just instantiate a connection app and provide the OpenAPIFire, and the framework take care of the rest. So here we have our OpenAPI file, and yeah, it's very, very simple. Here, for example, we can see regex validation that the framework will perform. We have return all the pets by ID, and here we have the different methods for creating pets and deleting. So yeah, we can give it a try from the command line. So I already have some calls. So here's, let's see which pets exist. So it's empty, and now create one. So here we're going to create a pet with here, well, I'm using HTTP for like making the API calls easier to read and understand. So here I'm going to provide a name, animal type, and some attribute called color. And yeah, it's what expects. Okay. Okay, yeah, let's try in the browser. Okay, it was created successfully, and yeah, let's see another cool tool from Swagger, which is the Swagger editor. Here we have our OpenAPI specification, and it provides like a web front end where I can like see the different entities and play with the API. So here I can see all the things that I wrote in the documentation. Here I can read and, for example, filter by tag. And we can either also send requests and let's see, interact with the API, which is really helpful for non-developers that are, for example, researching what's the scope of the API, and they want just to see how it works. All right, so Connexion doesn't have any dependencies with any platform. You can run it in your machine, in localhost, or deploy it in whatever platform is your favorite. But since this is a Google-related conference, I think it will be well cool to use the Google Cloud for hosting our Connexion-based API. So the simplest way to have your API in the cloud running, I would say, is with Google App Engine, which is platform as a service from Google. The main advantage is that it's fully managed, and you don't have to worry about anything from the infrastructure or the platform. You just write your code and deploy, and it's live in the cloud. So that is also auto-scalable. That means that if your application starts getting more traffic, Google will figure out like how many instances we'll need, and it will provision those server instances. It's highly available, so also Google takes care of that, so we don't have to worry too much about that. And another good thing, which is only in this version of App Engine, which is called Flexible Environment, is that it's based on Docker containers. And that means that if you want to like migrate to another platform, you can do it. And it's like an easy migration path, especially for a Google Container Engine, which is based on Kubernetes. So now is Google Kubernetes Engine, or you can migrate it to your own Kubernetes cluster, or if you want to run Docker in Google Compute Engine in a virtual machine, you can also do it. So there is no lock-in with the platform. You can take your application elsewhere. All right, but since we are talking about APIs, I think this other tool is more relevant right now because it will provide more visibility in how our API is performing, and it has many features around this. The name is Google Cloud Endpoints, and it is API gateway, and it provides additional functionality specific to APIs backends. So one of those, the main things that it takes care of is the access control and authentication, but it also provides other features like login, monitoring, metrics, and always keeping in mind that, well, it doesn't have to be the single point of failure like other API gateways, and it's super fast and also scalable. Like it will scale next to your application. We'll see the architecture next. And there are some nice features that are being added. So one is quotas. So you can define, for example, okay, I want this customer to only call my API 10,000 times a day, or yeah, have limits in your clients so they don't like overwhelm your service and you spend too much money or waste too many resources. Or also another feature that is now in alpha is API development portal. So similar to what Google has, what Google offers. that you provide a portal for third-party developers to interact with your API, and yeah, that's also something coming. Okay, so this would be the architecture of an application running using Google Cloud Endpoints. So everything starts again with the OpenAPI specification. So you have your OpenAPI YAML and you deploy it to this service management and control part of the Cloud Endpoints service. And with that comes the second component, which is the ESP, or Extensible Service Proxy, which is a proxy server based on Nginx. It's fully open source, and the responsibility of the ESP is to validate that all the requests are compliant with your API definition. So it will make sure that your that the path exists in your API spec, and it will make sure that all the parameters are there as well, and of course the authentication. So if you require authentication, it will validate the token before the request is sent to your server, and is thin and fast, and that's because it's not. It doesn't require another network call. It will be co-located with your application. So in the case of App Engine, it will be a container that is already provisioned with the whole application. In the case of Kubernetes, you can manage this other container, and it will be in the same pod. So it doesn't have to travel across the network to send the request to your API container. And it also provides a dashboard, web UI, where you can see all the metrics, all the logging related to your API. Okay, so I mentioned like the main feature is the authentication, and it provides support for many types of authentication. The API keys is the first one, and this is not like authentication for user, is more for applications or customers. So you generate a key, API key, and the customers of your API will include this key in all the requests, like as part of the, as an extra parameter. And you can revoke those keys. So if, for example, it's no longer your customer, you just revoke the key and they will no longer be able to use the API. And then you can also filter all the requests by a specific customer and see how the customers are using your API. It also supports, of course, Google accounts. So if you are developing an app that requires a Gmail or a G Suite account, then you can use this method. It's really simple, it's already built in. Or if you want to outsource or delegate your authentication to a provider like Firebase Out or Auth0, it also supports GWT tokens, and also service accounts, which are for server-to-server communication. So in this approach, here we can see an example. You have to tell Google Cloud Endpoints which is the issuer of the GWT token, and you also have to provide a certificate for the ESP to validate the token against this certificate. So you will make sure the signature is valid, and with that, it will forward the request to your API container or your implementation code. And here we can see in Connexion, we have a way to get the headers of the request, and that header will be injected to all the requests. So it will be encoded in base 64, and we can decode it easily and know who was the authenticated user of that request. Okay, so now I want to show a demo where we can see the configuration of App Engine and Cloud Endpoints and different kinds of authentication, and of course the dashboard. So the configuration of an App Engine application is extremely simple, like just this Python, this YAML file. So we have to specify the runtime, in this case Python, and we have to tell, okay, which flavor of App Engine are we running, and this is a flexible environment. Here, since it's a demo, I don't need the automatic scalability. I'm just setting one instance, and yeah, the next instruction is, okay, the entry point will be Wicorn and, well, our app. We also tell them that this is our requirement for Python version, which is Python 3. And here is where we link our App Engine application with Google Cloud Endpoints. So when we deploy the OpenAPI YAML, we will get this configuration ID. And now the ESP will know that this deployed code will match this deployed OpenAPI spec. So that's all we have to do for App Engine and Cloud Endpoints. And yeah, for the authentication, I just made many different endpoints for trying out all the authentication options. So yeah, I'm just looking, using this out info function, and here I'm just decoding what comes in the X endpoint API user info header. So let's see it in action. Okay, so I already have here. So I have a key already generated. Okay, so we will try to call this API endpoint without the key, and it shouldn't work. Okay, so we get error. Please use API key or other form of API consumer identity. So okay, so the difference between the previous call and this one is that I'm including the this key parameter and putting the endpoint key there. Let's try it again. Okay, there is something wrong. Okay, there it is. So it works. And the other thing that I want to show is the integration with authentication providers. So I have this front-end application which basically call the API endpoint and then return like the authentication information. So here I'm already logged in. So since the current authenticated user, the ID, and who was the issuer of the token. And this is using Firebase out. And let's try it out with Google accounts. And then we see kind of the different authentication options supporting that Cloud Endpoint supports. So since I don't want to go through the whole source code, I made this GitHub project, and you can see here the backend code and the different front ends. So I will include this in the slides, so you can watch it later. Oh, and I forgot the dashboard. So here I'm in the Google Cloud Console in the Cloud Endpoints section. And here I can say, okay, I want to see the metrics like from the last 7 days, 14 days, 30 days. And we'll have graphs that show me the amount of requests and the percentage of errors. Yeah, like these are like API-specific metrics that I'm tracking, and I can see here the amount of requests and for example, the latency of every operation. So I think this is pretty useful if you are doing providing APIs to third parties or tracking your own internal APIs. Okay, some caveats with this setup. The first one is related to the OpenAPI version. Right now, there is a new version of the specification, which is OpenAPI version 3, but both Connexion and Google Cloud Endpoints support the version 2. This will change soon, I expect. There are already developments going on. And well, for Google Cloud Endpoints, not even all the features of the version 2 are supported. So here I put a link with the specific details. The next caveat is Connexion provides some goodies, like automatically importing the Swagger UI. And if you use it in conjunction with Cloud Endpoints, you will lose the Swagger UI and also the generation of the JSON file based on the YAML file. So yeah, keep that in mind. And Connexion also has one feature when you can call variables inside your OpenAPI spec. And since we need to have a static YAML file for Cloud Endpoints, we also lose that feature. And regarding App Engine, this works in the flexible environment, but the other flavor that App Engine has, called a standard, that requires that we use the Google Cloud Endpoints framework, not other framework like Connexion. Okay, so to finish, I would like to first, well, like API first is an interesting strategy, and it's not only about the tools, it's also about the practices and the principles that your organization needs to follow. So it requires some, like, that it's part of the culture. Second, you need to find the right way to strike a balance between having the specification and the code up to date. So today I show you one possibility, which is a Connexion, but you can also take a look at other approaches. And well, the most important thing here is the value you provide with your API. So using Google Cloud, you can focus on your API and your functionality and leave the infrastructure to a cloud provider like Google. Okay, here are some interesting articles I use for the talk, and also the sample app and the repo. And that's it. Anyone have any questions? Yes, I will send the presentation to Natalia, and she will put it somewhere. Or another question? Okay, thank you very much.